Hi class, this is Dr. Karsten, and today we are doing lesson 33, and this is from Mod 5, Grade 4, EngageNY Math. This is a reposting of this lesson. The first one, the volume was not great, so hopefully this one will work better. I did a sound check before the first one and everything was good, so something must have been jostled. I just did another sound check and I think everything's good. But because I am doing this in the middle of the day, you are probably going to hear noises from my family. I am trying to get everyone to be quiet, but I apologize in advance. Of course, this is when saws are suddenly being used and things like that. But I want to get this out to you as soon as possible so that you can work through it today and bring me any questions to our Google Meet. So we're going to jump right in. Today's lesson is all about, sorry, I was just thinking about something else for a second. It is all about subtracting mixed numbers from mixed numbers. So it's building on yesterday's lesson where we were subtracting a fraction from a mixed number. Today we're just going to the next level where we're going to take a mixed number and subtract it from another mixed number. So let's go ahead and get started with this. So for today's lesson, the first problem that we're going to work on is we are going to take 4 and 3/6. And from that, we are going to subtract, let me bring my notes that I have over here. From that, we are going to go ahead and subtract 2 and 5/6. Now, the first way that I want to do this is I want to use a number line. And our focus today is not going to be on number lines, but I am going to do a couple of them for you. And part of the reason is that we are going to use a different strategy using number line than we've done before. So I just wanted to mention that to you, that we are going to be using two different number line strategies. So let's go ahead and do the first one. And the first one is what we've been doing and what we did yesterday, where we're going to go ahead and use the number line, and we're first going to put in our whole numbers. So since I'm starting at 4 and 3/6, I know that I'm going to need a 4, and I also should have 5. And then I'm going to go on down the number line. Now since we haven't done this yet, we really don't know how far we're going to go. So I'm going to go ahead and take it all the way down to 0 for us. So the next thing that we have to do is we have to partition our number line. We have to cut it up into pieces. And we know the size of the pieces because we can see that we have 6th in the denominator. And when you have 6th in the denominator, you need to, we have to go ahead and cut it up into 6th. We have to partition it into 6th. So I like to model this for you. That's why I don't have it all set up, because I like for you to see how I do that. And you can see that since I'm cutting it up into 6th, I need to put 5 lines in the middle. Whenever I have an even number in the denominator, I always put the half in first. Helps me out. Okay, and there we have it. So, I really want to emphasize where our whole numbers are. So I'm just going to darken those up for us because I think that's really important. Okay, so now that we have drawn our number line, what I have to do is I have to show where I'm starting, which is at 4 and 3/6. So I'm going to go to the 4, and then I'm going to count up 3/6. So 1 6, 2 6, 3 6. And this is where I'm starting. So I'm starting at 4 and 3/6. Now to subtract, the first thing that I can do is I can actually subtract those 2 wholes. And this is just one way. There's lots of different ways to do it, but this is the way I'm going to do it right now. So since I'm at 4 and 3/6, I'm going to hop down to 3 and 3/6, and then to 2 and 3/6, because all I did was I subtracted 2 from that 4. If I subtract 4 minus 2 wholes, I'll get 2 and 3/6. And so that's what's going to land me here. So now I'm going to model that with an arrow, and I'm going to write what I did, which was I subtracted 2. Now what I'm going to do is I want to subtract that 5/6. So I already subtracted the 2. Now I need to subtract 5/6. So I'm just going to go ahead and do that. 1, 2, 3, 4, 5. And that lands me right here. I'm going to put another arrow and show that I subtracted 5/6. And where does that land me? That lands me at 1 and 1, 2, 3, 4, 6. So that's my answer, 1 and 4/6. So that's one way that I could use a number line. I could have also gone down to the 4 and then hopped down 2 and then hopped down an additional 2/6. That would have been fine also. But I don't want to confuse you too much by doing a whole bunch of these. But if you're comfortable with this, you absolutely can use this as a technique for working with the fractions and subtracting. So now let's do a slightly different number line. And I'm going to go ahead and give you your first code word, which was distracting me before. So your first secret code word is chicken. C-H-I-C-K-E-N, chicken. C-H-I-C-K-E-N. So that's your first code word, chicken. All right, so now let's do a number line, but this time we're going to use counting up or counting on as our strategy. So a lot of you have used this in the past. So for example, let's say I was doing 7 minus 5. A lot of you will say, well, I'll start at my 5 and I'll count up to 7 to see what's different about them. So you go 5, and then you go 6, 7, and you know that there's 2 to get to the 7. Well, we're going to do the same sort of thing, but on a number line. And again, if this is confusing to you, don't worry. We're going to get to the strategies that you're more comfortable with. I did want to review this, though, because it is good to visualize. And it's also good for us to use it. For some people, this is just how they understand this better. And this is how their brains work. So we're gonna do it this way first. So again, I'm going to go ahead and put in my ones, and I want to kind of darken those because I think they're good to have. 4, 3, 2, and I know we don't have to go beyond that 1, so I'm just going to put the 1 in. And then again, because I have 6 in the denominator, I know that I need to partition these into sixths, so I'm going to go ahead and do that. So there we go. And I'm just doing it quickly. They're not perfect, but we know they're supposed to be equal. So there we have it. All right, so for this, what I'm going to go ahead and do is I am actually going to mark off 2 and 5 6, because again, we're doing counting on or counting up. So I'm going to find 2 and 1, 2, 3, 4, 5, 6. So that's 2 and 5 6. And I'm also going to mark off 4 and 3 6. So this is 4 and 1, 2, 3, 6. And now what I want to do is I want to figure out what is the difference between this. How far do I have to go if I count up or count on to get to that 4 and 3 6? So the first thing that I'm going to do, and let me grab a different color, is that I want to get to the nearest whole number if I'm doing this technique. So I'm going to go from 2 and 5 6, and I'm just going to hop up to that 3. And what I did was I just did 1 6. So I added 1 6 on. Now I'm going to count my whole number. So I'm going to hop up from 3 to 4, so that's plus 1. And now I need to see how many more sixths do I need to add on to get to 3 6. So I'm going to go 1, 2, 3. So that's adding on 3 6. And now I can just combine all of those. So for this one, I would have 1, and then I have 3 6. Plus 1 more 6 is 4 6. So we're going to get the same exact answer, which is that it's 1 and 4 6 to do that entire hop. So to go from here to there is 1 and 4 6. I may have to pause to take the puppy out. He was just out. I'm not really sure why he wants to go out again. I think maybe because some of the people are outside and he wants to go play. All right, so we have 1 and 4 6. So now that we've done this using number lines 2 different ways, first we did it the way we done it the day before, where we started at 4 and 3 6, and we subtracted the 2, and then we subtracted the 5 6. And then we did it using counting on or counting up, where we started at 2 and 5 6, and we counted up to 4 and 3 6. All right, so now let's do it the other ways that we know. Let's try doing it the horizontal and the vertical ways that we've been doing this. So let's go ahead and start with our number sentence. So we have 4 and 3 6, and we want to subtract from that 2 and 5 6. Yeah, he just wants to be with everybody. Let me see if I can go find him a buddy. All right, hopefully he's happy now. So when we're subtracting a mixed number from a mixed number, what we are going to first do is we're going to subtract, if we're doing it this way, we're going to subtract that 2 from that 4. So let's subtract that out. So if we did 4 minus 2, so we're going to subtract the 2, I'm going to be left with 2, and we can do it on the side. 4 minus 2 is 2. So I'm going to be left with 2 wholes, 2 units, right? And then I'm still going to have my 3 6. And now I'm just subtracting that 5/6 from it. So the first thing that we did was we subtracted 4 minus 2 and got 2. We held on to our 3/6. And we went ahead and now we're going to subtract 5/6. This is exactly what we did in that first number line, where the first thing we did was we subtracted out the 2 and then we subtracted out the 5/6. We're doing the exact same thing. So now the thing that we learned to do yesterday when we were working with these, and this is just like yesterday's lesson, is we learned to decompose 5/6. And what we want to do is first we want to be able to jump down the 3/6. I'm going to write 3/6. And then we are going to have 2/6 left. And that's because 5/6, if I have 5 pieces, I put 3 here, I'm going to have 2 pieces over here. So the 3/6 and the 3/6, 3/6 minus 3/6 is 0, so those are going to cancel out. And what I'm left with is 2 minus 2/6. So let's write that. And I'm doing every single step for you guys right now. So we have 2 minus 2/6. Well, I can't take 2/6 away from 2. I need to somehow get a common denominator. I need to work with this. So what we're going to do is we're going to decompose 2 into 1 and 1. But instead of writing 1, I'm going to write 6/6. And that's because the rule for this problem, since we have 6 in the denominators everywhere, is that 1 is equal to 6/6, or 6/6 is equal to 1. And we always have that rule on the side to help us out. So now I have that 2 is the same thing as 1 plus 1, or 1 plus 6/6, because that's just 1. And now we want to subtract from that 2/6. So now let's just deal with this part of it. 6/6 minus 2/6 leaves me 4/6. 6 pieces minus 2 pieces leaves me 4. But I still have that 1 added onto it. So we'd have 1 plus 4/6 though, which is the same thing as just 1 and 4/6. And there we got the same answer. So again, what we did for this one was first we subtracted out the 2 from the 4, which left us 2 and 3/6. Then we still had to subtract that 5/6. We decomposed it so that we could get rid of the 3/6. So that would leave us with the 2/6. So we had 2 minus the 2/6. And then we decomposed that 2 into 1 and 1. And then we went ahead and we converted it into 6/6. We decomposed it into 6/6. So 6/6 minus 2/6 was 4/6. And we still had our 1. So we had 1 and 4/6. So if this is confusing you, don't worry. We're going to do it the other way. We're going to do it the vertical way now. So let's go ahead and set that up. So remember, I want to remind you, what we were doing yesterday and the way I explained it was, now this is not the vertical way, this is just a quick explanation. Let's remember, if I wanted to subtract 43 minus 25, remember what we would do. 3 cannot take away 5, right? We can't subtract 5 from 3. So what we want to do is we want to go and take that 4, make it a 3, and then that 4 sends over 1 10, which becomes 10 ones. Now we don't write like 10 ones here. What we do is we go ahead and we change this to 13. And that's because we sent over 1 10, which is really 10 ones. So we sent over 10 ones, but we still had that 3 there. So it became 13. And you know how to do this automatically. This is something you've been doing a lot. And then you just do 13 minus 5, which is 8, and 3 minus 2 is 1. So you're used to doing it this way. You know how to do it this way. Well, we're doing the same thing with the fractions. Only now we have fractions instead of having 1s and 10s. So let me go ahead and write for us what our problem is for this one. So we have 4 and, oh, I want more space than that. That's not going to work for me. So we have 4 and 3/6. And we are from that going to subtract the same thing as before, 2 and 5/6. And our rule again for this one is that 1 is equal to 6/6 because we have 6 in our denominators. Okay, so I cannot subtract 5/6 from 3/6. It's not going to work. I don't have enough pieces. So we're going to do the same thing that we did in the other problem. We're going to take that 4, make it a 3, and it's going to send 1 1 over. And I could write it like this. I could say that now I have 1 and 3/6. But that's not going to help me either. I need to turn that 1 into 6. So if I have 1 and 3/6, another way of writing this is to say 1 plus 3/6. And another way to write that is 6/6 plus 3/6, which gives me 9/6. Now, I hope everyone remembers our shortcut. Our shortcut was that I could have just added 6 plus 3 to get that 9 and held on to my 6. So then we would have 9, 6. So either way, you have 9 sixths. You could have done the shortcut. When I move the 1 over, I just go 6 plus 3 is 9 and keep it in as 6. And now, I'm going to cross that out. We have 9 sixths minus 5 sixths. That's really easy. 9 sixths minus 5 sixths. 9 minus 5 is 4 sixths. And 3 minus 2 is 1. So we end up with 1 and 4 sixths, exactly how we did it before. Don't worry, we're going to do a couple more examples before we move on. So let's try another one of these. Let's work on 11 and a fifth. Sorry, pup. Every time he sees someone, he wants them. 11 and a fifth minus 2 and 3 fifths. Okay, so we're going to do this one horizontally first. So step 1, 11 minus the 2. We're going to subtract the whole number. So 11 minus 2 leaves me with 9. So that's gone. And I still have my fifth. I didn't do anything with that. And I still have my 3 fifths. So now instead of having 11 minus 2, we have 9. Popsicle, shh. So now what I want to do is I want to decompose this 3 fifths so that I can subtract out that 1 fifth. So remember, we're going to have 1 fifth, 3 fifths. I put 1 fifth here. That leaves me 2 fifths over here. And now what I can do is I can say, and I can bring this down for us. So we're subtracting these out. These are going to be gone. 1 fifth minus 1 fifth leaves me with just that 2 fifths and that 9. So now we have 9 minus 2 fifths. And now what we're going to go ahead and do is I can't just subtract this. I need to get common denominators again. So I'm going to decompose that 9 into 8 and 1 minus 2 fifths. And it's 8 plus 1 minus 2 fifths. But instead of 1, let's make that 5 fifths. Sorry, my head was going back to the other one. So we have that 8 plus the 5 fifths minus 2 fifths. I'm going to slide that up for us. So now I can do this. Now I can take 5 fifths minus 2 fifths, and I get 3 fifths, and I still have that 8. So we end up with 8 and 3 fifths. So I hope that this is starting to make more sense for you. Just looking at where I was, I have my notes here from yesterday still. Oh, there we go. Okay, so now that we did it horizontally, let's go ahead and let's try it vertically. So we're going to do the same problem, but we're going to do it the stacking and subtracting way. So I'm going to go ahead and move this out of our way. Oops, sorry. Oh, I hope I didn't just mess up the volume by hitting that. Okay, so now we're going to do it the other way. We're going to have 11 and 1 fifth. And we're going to have minus 2 and 3 fifths. Okay, so for this one again, now our rule, we're going to look at our denominator, and our rule is 5 fifths is equal to 1. Hold on, let me take care of that. All right, so we're all set up. We know what our rule is for this problem. That can help get us out of trouble. So the first thing that I want to do is I want to see, can I just subtract 3 fifths from 1 fifth? And I can't. I don't have enough pieces here. I only have 1 fifth. I can't subtract 3 from that. So what we need to do is we need to go ahead and take this 11. We're going to make that a 10, and we're going to send 1 over. So this really becomes, and I'm just going to write it over here, 1 and a fifth. But 1 and a fifth isn't going to do me any good either. I need to convert that 1. I need to decompose it into fifths. So I'm going to have 5 fifths plus 1 fifth, which is 6 fifths. So that's what we're working with now. Now, if I had just gone over and I wanted to do the shortcut, if I wanted to do the shortcut, I'm going to pause this while they leave. Again, sorry, noisy house today. Okay, so instead the shortcut would have been, I could have written my 10, so I could have my 11, cross it out, put 10, and when I move the 1 over, the shortcut is to just say 5 plus 1 is 6, and I keep my denominator the same, which is fifths. And you see we got the same thing, doing it either way. So that's the shortcut, just 5 plus 1 is 6, and keep your 5. I'll explain really quick. The reason for that we can do that is since our denominator is 5, we know we're moving over 5/5. So the denominator is telling us what the numerator is right here. So that's why you can do the shortcut of 5 plus 1. All right, so now we're good. We have 6/5. We can definitely take 3/5 from that. So 6 minus 3 is 3, and I keep my denominator the same. And 10 minus 2 is 8. So we have 8 and 3/5. So we got the same answer both ways. Sorry, I was just looking at my notes. I'm like, I was looking at the wrong page because I like to make sure that I'm doing things right as we go along because we're all human and I could make mistakes. So we have 8 and 3/5. So we're good. So I would like to do just one more quick example of this, and then I'm going to move you into we'll move into the problem set together. But before we do the next example, I'm going to give you your second word, and your second word is duck, D-U-C-K, duck. So again, duck, D-U-C-K, duck. All right, so our next problem that we're going to work on is going to be 4 1/8 minus 1 7/8, and we'll do it horizontally and then we'll do it vertically. You pay attention to the one that's working for you. So again, the first step when we're doing it horizontally is we're going to subtract the whole number. So 4 minus 1 leaves me with 3, and I still have my 1/8. So I've taken away that 1. I still have to now subtract 7/8 from this. So I had 4 1/8, I took away 1 to get 3 1/8, and now I have 3 1/8 minus 7/8. Now, I cannot take 7/8 away from 1/8. 1/8 minus 7/8 is just not going to work. So I need to decompose 7/8. And remember, we want to be able to subtract that 1/8 out. So I'm going to put 1/8 and 6/8. So 7 becomes 1 and 6. So now we have 3 and an 8, and we're subtracting these out. So now 1/8 minus 1/8 leaves me with 3 minus 6/8. So we have 3 minus 6/8. I cannot take the 6/8 away from 3 because I need to get a common denominator. So I'm going to go ahead and decompose 3 into 2 and 1. But instead of writing 1, our rule for this problem is going to have to do with our denominator, which is 8. So our rule is that 1 is equal to 8/8. So I'm going to write 2 and 8/8 minus 6/8. And I'm going step by step. You would not have to do step by step if this is how you're working. So now what I'm going to do is I'm going to do 8/8 minus 6/8. Uh-oh, we have a problem. All right, so back into this. All right, so where we left off was that we had our 2 plus 8/8 minus 6/8. So 8/8 minus 6/8 gives me 2/8. And we still have our 2. So we have 2 and 2/8. And that's going to be our answer. So now let's do it vertically. Let's stack them and subtract them. So let me switch pages. See, now you guys know why I post these videos late at night. Because it's quiet. I can do a video. Okay, so our next way that we're going to do this is we are going to go ahead and we are going to stack them and subtract them. So we start off with the same numbers, 4 and 1/8. I'm just leaving myself some room to work. Minus, what was it, 1 and 7/8. All right, so to do this time, I go ahead and I look. Oh, let me write my rule. Since I have 8 in the denominator, I know that 1 is equal to 8/8. Okay, so this time we're actually going to do it just with the shortcut first. So I cannot subtract 7/8 from 1/8. It's not going to work. So I'm going to make that 4 a 3 and send 1 over. And when I decompose and when I send 1 over, remember our shortcut? 8 plus 1 is 9, and I keep that denominator. That's the shortcut. Let's show why. When we send 1 over, we have 1 and an 8th. Another way to write that is that 8/8 plus 1/8, which is 9/8. So we get the same number regardless of which way we do it. Okay, so now though, pretend we didn't have to do that. We did our little shortcut. We made that a 3. We did 1. 8 plus 1 is 9/8. So now I can go ahead and subtract. 9/8 minus 7/8 leaves me 2/8. And 3 minus 1 leaves me with 2. So we got the same answer again. And I just want to do one more really quick with just doing the trick, just to really reinforce it for you and show you how quick it'll be once you master doing it this way. So watch, we're going to start with 5. We're going to do 5 3/5 minus 2 4/5. So now I'm going to write my rule even though I don't really need it, but it is a good habit. So I know that 5/5 is equal to 1. You can write it either way, 1 equals 5/5. So I cannot subtract 4/5 from 3/5. So I'm going to go ahead and make that a 4, send 1 over, and the shortcut is 5 plus 3 is 8, and I keep my denominator, which is fifths. And now 8/5 minus 4/5 is 4/5, and 4 minus 2 is 2. And we ended up with 2 4/5, which was totally random. That would be the same thing as what we were subtracting. But do you see how nice and quick it is when you do it this way? Especially if you know your shortcut. But if you don't know your shortcut, you could have done it the longer way and added 5/5 to 3/5 to get 8/5. Okay, so let's jump into the problem set. I think we're good and ready to go with that. So let me grab that for us. And I don't want to have this stuff peeking through the paper, so I'm going to pull that away. Oh my goodness, I'm going to have all these papers. Okay, so in the problem set, the first thing I want to really emphasize to you is that you can do these the way that you are comfortable. You do not have to go crazy and do it exactly how they are requesting it, with one small exception. I do want us, just for number 2 down here, I do want us to use a number line. So I do want us to try using a number line just for here to model this. And I'm going to show you how I would do that with this problem. So if I were doing this, and here's the problem, you know, again, I'm not always happy when they do all this craziness for us, and I know it's good that they model it, but that's the problem we're working with, which is 3 1/4 minus 1 1/4. So I am going to not do the counting up way, I'm going to do it the other way, and I'm going to model using the number line that way. So I'm going to go ahead and draw our, oh, I did not leave us enough room about that. That's going to kill me. But here we go. Okay, so again, since I'm starting with 3, I'm going to put 3 on here, and I'm also going to put 4 on here. Then I'm going to put 2, and I'm going to put 1. And even though we know that we're ending between 1 and 2, I'm going to go ahead and put the 0 down there, as if I didn't know that yet. So now, sorry, let me just grab a drink. So now, since we have fourths in the denominator, let me partition these off into fourths. So I'm going to go ahead and mark in my fourths. And now I want to show where I'm starting. So we're starting at 3 1/4. So yesterday I used a different color, so let's kind of be consistent with that. Oh, I don't think this purple is the good one. This is the better one. So we're starting with 3 1/4, so I'm going to go to 3 and then add 1/4. And that's where we're starting, 3 1/4. So the first thing that I want to do is, since I'm subtracting 1 3/4, is I'm going to hop down 1 whole. So 3 1/4 becomes 2 1/4. See, if I subtract 1 from 3, I get 2. So I'd have 2 1/4. And that's going to be right here. So that's subtracting 1. And that lands me at 2 1/4. And I'm going to go ahead and write that in because I like to do that. So now I subtracted that 1. Now I need to subtract 3/4. So I'm going to go ahead and do that and hop down 3/4. So here's 1/4, 2/4, 3/4. And that lands me right there. So let me model what we did. We subtracted 3/4. And now where did I land? I landed at 1 1/2/4. And that's our answer, which you can see right there. Okay, so that's the way that we can use the number line. Now I feel like you guys are going to be able to do that yourselves, and I'm going to have you do that. I think I had down that you're doing 2B as part of your work. So I do want you to practice using a number line, and you can do it either way, counting down or counting up. Whichever way you're more comfortable with is fine by me. All right, so let's jump into the problem set, the rest of it, because that's really where the bulk of your work is going to be today. And I'm going to do 2 of these with you, just to emphasize what we're doing. Oh my goodness. No way. When I made up that problem, yep. All right, so let's take a look at this and see how it's going to go. I think we already know. So here it says, subtract as shown in problem 3a by decomposing to take 1 out. So what I really want to emphasize with you, again, is that you can do this however you are comfortable. I want you to do it whichever way you are comfortable. So I'm going to cross that out. If you want to do it that way, go ahead and do it that way. But we're going to do this one as a solving any method. Okay, so since they did it this way for us, and you can see here what they did, I'm going to do it the other way. So I'm going to go ahead and I am going to do it the vertical way, just to kind of emphasize that with you. So we have a lot of room over here for me to work. So we're doing 5 3/5. I know we kind of already did this. So I'm going to do 5 3/5. I should have left myself more room above that, sorry. Minus 2 4/5. All right, and I do like to kind of highlight what the problem is. And there we have all that stuff. And again, I'm going to write my rule because we have fifths. So I have that 1 is equal to 5/5. Okay, so 3/5 cannot subtract 4/5. I cannot take 4 from 3. It just doesn't work. So what we're going to do is that 5 is going to become a 4. And first I'm just going to do the shortcut. So he's giving 1 over. So we're moving 1 over. We're going to decompose it. So let's regroup. So we have 5 plus 3 is 8, and we're going to keep our denominator. So remember that shortcut. Let's show why. So we moved 1 over, so we have 1 3/5. But that's not going to help us, so we change that 1 to 5/5. And we still have the 3/5. And then we combine them to get 8/5. So that's why we can use that shortcut. So now 8/5 minus 4/5 is 4/5, and 4 minus 2 is 2. And yes, that should have been super familiar to you. Okay, so we got the same answer. We're all good. So now let's go ahead. Oh, they never finished this out. Well, you know what? I'm going to let you guys, I'm going to let you guys do it whichever way you want. I actually am not thrilled that they did it that way. So let's go ahead and let's go down here and let's take a look at D, because D is the one that I did in the other video as well. So I do want to go ahead and work through that one. So we're going to do it 2 ways. We're going to do it the horizontal way, and we're going to do it the vertical way. So if I'm working with this, remember the first step is that I'm going to do 5 minus 2. I'm going to subtract my whole numbers. 5 minus 2 is 3. And then this 2 is gone. This 5 is going to hold on to that 1/100th. So we have 3 and 1/100th minus 97 100ths. We're just doing it step by step. So now I cannot subtract 97 100ths from 1 100th. It's not going to work. So what we're going to do is we're going to decompose this 3 into a, oh my goodness, I just skipped a step. Sorry, I was looking at it. So, nope, we're not going to decompose our 3 yet. We're going to go ahead and we're going to take this 97 100ths, because first we want to be able to subtract out 1 100th. So we're going to decompose that to match this. We have 1 100th, and we're going to have 96 more hundredths, because 1 plus 96 is 97. So now these two, we have 3 and 1 100th, subtracting out both of these. And these are going to cancel out. 1 100th minus 1 100th leaves us with 0. So now we're just left with 3 minus 96 100ths. So now what I want to do is I want to go ahead and decompose my 3 into 2 and 1. But instead of writing 1, I'm going to write 100 100ths. And that's because my rule for this one is that 1 is equal to 100 hundredths, because we have 100 in the denominator. So this 3 becomes 2 and 100 100ths. Now we're going to subtract out that 96 100ths. And 100 minus 96 leaves you with 4 100ths. Oops. And we still have our 2. So that's one way to do it. Oh, and I went off camera. All right, so that was just such a mess. So I'm going to go ahead and I'm going to redo that vertical way for you right now on a separate piece of paper, just because I am not happy with what I did. So here we go. 5, and I'll do it quickly. 1 100ths minus 2 and 97 100ths. So let's clean this mess up. All right. So first we're going to subtract 5 minus 2. And then we are left with 3 and 1/100th minus 97 100ths. So now what I want to do is I want to decompose 97 100ths so that I can work with it. And I want to be able to subtract out that 1/100th. So we're going to have 3, and I'm going to just pull this apart for us so we really see it. 3 plus 1/100th minus, and now we're going to decompose this. We're going to have 1/100th because that's going to let me subtract. And we're also subtracting from that the 96 100ths. So this is what it really becomes. It becomes 1 and 96. 97 minus 1 is 96. But if I'm looking at this problem, I'm subtracting both of those from this. These cancel out, and I'm left with 3 minus 96 100ths. But I can't do that. I need to get a common denominator. So we decompose the 3 to 2 and 1, but instead of writing 1, I write 100 100ths, because 1 is equal to 100 hundredths. And now from that, I'm going to subtract out that 96 100ths. And that's going to leave me with 4 100ths. And I still have my 2. So I have 2 and 4 100ths. Okay, now that that's sort of cleaned up, let's go ahead and do it the vertical way. A lot fewer steps when we do it the vertical way. You know, let me grab another color like I did last night because I think it makes it more clear. Okay, so I have 5 and 1 100th. And I'm going to subtract from that 2 and 97 100ths. So first things first, I cannot subtract 97 from 1. So I'm going to go ahead and make that 5 a 4. And then I'm moving 1 over. We're going to use our shortcut, which is 100 plus 1 is 101 100ths. We keep the denominator. The longer way again, and I don't really have a lot of room here, I'm going to try. When I moved the 1 over, I had 1 and 100th. I can change that 1 to 100 hundredths plus that 1 100th. And then that becomes 101 hundredths. So that's the longer way. We get the same answer, 101 100ths. Okay, so we have 101 100ths, 101 minus 97. If you want, you can count up. You can do it on the side, whatever works for you. But either way, you're going to get 4 100ths. And then 4 minus 2 is 2. So we got the same answer both times. Okay, so I hope that that was clear. I hope that it's all making sense for you. Again, you're going to finish out problems 3 and 4 from this page. So for problem 3, you're going to be doing BC, and for problem 4, you're going to be doing ABC. And that is it for today. So I hope the sound quality was better, and I'm going to quickly go and get this posted to our Google Classroom. All right, have a great day, everyone. I'll see you tonight in our Google Meet. Bye.